Differentiation will not talk about anything about the basics of differentiation and the basics of partial differentiation. I assume that you have already known the stuff that is required, but in this series we'll talk about what are the types of exam questions that may come out. So I will assume that you are already professional in your partial differentiations, right? So if you are not very professional in here, I would suggest that you can actually watch this video. You can search partial differentiation. The first two videos is very good. It comes from Patrick and Khan Academy. If you want to know just how partial differentiation works, the simple method, I would suggest you watch this one. If you want to know in depth of how it is being visualized, then I highly recommend you watch this series, okay, and the part 2 and so on, which is very helpful, and I think that it can really helps. But if you just want to ace for exam, I think that I could help you here. So to start off with this, I'll just do up a test questions that is, in fact, partial differentiation normally they would ask you to prove certain things, right? So in this question that I'm writing currently right now is to give you an intuition of how to prove. Okay, so the questions, this is the function, a function of x, y, and z, right? It's pretty fine. So you have to prove that this function, alright, this dude over here, this whole chunk over here, satisfies fx plus fy plus fz is equals to 1. So what the hell are these things? Fx, f subscript x is equals to partial function over partial x. This is just the meaning. So you're gonna differentiate this whole equation in terms of x, and then addition with, you're gonna differentiate this whole equation in terms of y, plus addition, you're gonna differentiate everything in terms of z. Alright, so I'm gonna share with you how are the methods to approach, and I assume that you are very professional in quotient, because since we're gonna do something like this, and simple differentiation. Okay, so I would really highly recommend, if you don't know anything about this, go and search it out, okay, or you can just press the link over here and over here, then you can just see what are the videos that they can help. And therefore, without further ado, let's just start off with doing this question. First of all, partial differentiate this whole equation in terms of x. Alright, so fx is equals to partial x is equals to, this is the function x. But instead of writing that, I actually split it out into y minus z. Right? So x over y minus z. So this whole chunk, here can be rewritten as what I'm gonna rewrite over here. Okay, so what I'm gonna rewrite now is to write this. So this will be slightly better for in terms of this situation, because I just want to differentiate in terms of x. So if you do differentiations in terms of only x, I would have x differentiate, you have just 1 plus, if you differentiate x over y minus z, you're just getting back its constant, which is y minus z. In other words, this thing comprises of x times 1 over y minus z, right? So if you differentiate in terms of x, you're just getting back the constant here. So this is why I have this. If you don't know anything still, I would suggest you just go and just look up this video. Okay, I highly recommend you look up this video. I don't want to waste your time. So if you don't know anything along the way, you don't know what the hell I'm talking, then you should look up the things that I've just talked about in the introduction. Search it up, and then when you're fully done, then you can just come here and check it out, the cheat code for exam questions. Alright, so in this case I have the fx the partial x done. Okay, presumably I will assume that you already know what the hell am I doing right now. I'm just doing this thing over here. Now I'm gonna do this thing. I'm gonna also differentiate in terms of y in this case. So in terms, if I differentiate this function in terms of y, I would have, because this one in terms of y is just 0 plus, so if you have a variable, okay, so normally if you see something like a one variable at the top, another variable at the bottom, this means you're gonna use quotient rule. Quotient. If you don't know anything about it, I think that you should also, go and I just put it inside the introduction, so you should go and check it out. Right? Meaning the first few minutes of this video. But anyway, I will assume that you know quotient rules already. If you don't know, then you should go and check it out. So if I were to do that, I have to use quotient rule. And quotient rule, what I do is to first elaborate the denominator. I'll differentiate the denominator first. So I put it up over here, 1. And then, is it? No, I am wrong. You have to differentiate the top first, and then keep the bottom, minus away. Okay, what I'm gonna do now is to differentiate the top first, the numerator. So I differentiate, I have 1. A minus 1, sorry, because I differentiate in terms of y. So differentiate in terms of y, I have minus 1 over here, right? And then I keep the denominator. I would really believe that you really know what I'm doing right now. I'm doing the quotient rule, minus away. Now I differentiate the bottom in terms of y. So I have 1, and then I keep the top x minus y. And then bottom y minus z squared. And this is your after you differentiate for your y. But you can rearrange, because the top itself, it's so be careful of the thing when you're doing this exam questions. You have to be careful of the sign when you multiply inside each of them. And also this thing minus 1 is gonna you're gonna multiply inside this things also, right? So this is a key understanding. So I have so I just write it in white color now. Okay, so I multiply in minus y plus z, minus 1 times x, I have minus x, and then minus 1 times minus y, I have plus y. So what I have back now is z minus x, because minus y and plus y is cancel each other. I have this dude over here. Okay, so I have finished up the partial function of x and y already. So now I'm gonna do up for the function of z. So because I have no space, I'll just copy this initial function. I just paste it over here for simplicity's sake to reference. So now I'm gonna do out the function of z is equals to partial f partial z. I think if you know what I'm gonna do next, then you just skip to the later part to see what I'm gonna explain. But if you want to understand how to deal with this stuff, then I suggest that you continue. Alright, so if you partial z, you know that this is gonna become 0 again. So 0 plus. So now I'm gonna same thing. Because this is the denominator, you can't do anything about it. The only way to differentiate this is by using quotient rule. Otherwise you can use actually no need lah. Can use this method, minus 1. Okay, so I'm just simply changing this. So 1 over y minus z is equals to y minus z inverse 1. This is how you're gonna rewrite things. If you forget or you are not aware of, then this is something I would suggest you should really know if you are really doing this stuff, because this is a common type of things that people always exam questions always asked. So if I differentiate, okay, in terms of z, alright, what I would have is minus 1 x minus y. So you're actually treating this as a constant, so you keep this all the way, and then y minus z minus 2. Okay, and then you differentiate the inner one. I believe you have understand the differentiation of all the product rule, chain rule. I believe this is the chain rule, I think, inner function stuffs. But if you don't know, then the chain rule is this is how it spells. If you don't know, then you just go and check it out. Alright, I'm not gonna do about that stuff. So once you do that, so the first things first is to differentiate the exterior one. So I bring this down over here, which is what I've written over here, and then I differentiate the inner one, inner function. I would have plus 1, minus 1 times minus 1, because if you differentiate this minus z, you have minus 1, right? So this thing x together will become plus 1. So this is simply what I'm writing, and therefore you can rewrite this as x minus y, and I just bring this dude down to the denominator, sorry. So I have y minus z square, and hence the function of the partial differentiation of z is this form, and then partial differentiation of x is this one, y is this one. So x, y, z. So I'm gonna put them all together so that I can sum them up together and prove that it is equals to 1. Okay, so what I'm gonna do is to paste this dude. This is the function of y, and this is the function of z. Okay, is equals to 1. So this is function of x plus function of y plus function z. Okay, and therefore what I'm gonna do is to just simply solve for using your simple math. Okay, I will assume that you already know, otherwise yeah, this is a recap. Okay, so to recap to you, what I'm gonna do now is to make all the denominator the same. Okay, so what I'm gonna do here is so I'm gonna make this square because everything is in terms of square now. Okay, so I multiply square over here, so I'm gonna multiply y minus z into this whole thing. Okay, this whole thing. So if I were to do that, then I have to write y minus z over here, and then this whole dude over here is y minus z square divided by y minus z square. Alright, so you can see that the numerator, I mean the denominator are all the same now. What I can do now is to settle all the numerators. Alright, the numerators. I mean my pen, I don't know where the hell my pen goes, but I think you know what I mean, the numerator. Okay, so I'll just write down all the numerator stuffs and then we elaborate from there. So currently what I'm just written down is only the numerator. So because the denominator we know is always y minus z square. Alright, so I'm gonna expand this dude using your simple math. I'm not gonna talk about it. So okay, but however after zoom already I realized that actually these things over here should cancel each other and become 0, and y minus z square, this means that this portion here should be equals to 0 because they will cancel each other. So in order to prove that, let's do it up together. So I use a different color. So y, maybe I use a slightly better color. Y, let's find out y minus y 0. Okay, minus z plus z is 0, minus x plus x 0. So everything becomes 0. So actually I don't need to expand that dude, I don't know why. So I'll just keep this dude over here, I bring it down, y minus what, z square. And you know that this is the only numerator, so I'll just filling back the denominator over here. So which is equals to 1. And therefore we have successfully proved that when you sub in your fx, your fy, and your fz, you get equals to 1. And this is one type of questions. I believe this is the only one, so-called the harder question type of partial differentiation that they will do, is to call you to prove. Alright, to call you to prove. If they want you just purely differentiate, then you're just happy, So that's it, and I will see you in the next video for chain rule, partial differentiation.